Hello, this is Jerry Collins from the Society of Cost Engineers. We're about to start our webcast. We have a few more minutes for others to join. Stay tuned. Hello, everyone. My name is Jerry Collins. I am the founder of the Society of Cost Engineers. Welcome to today's sponsor series webcast. Today's sponsor is Unison Cost Engineering. The Society of Cost Engineers basic membership is free thanks to all of our sponsors. The sponsor series is about giving the opportunity of our sponsors to show their capabilities to an audience. This webcast is going to be recorded and will be available on our website, www.societyofcostengineers.com. Gary Kokins will be our moderator today, and he will kick this off.
Great. Thanks, Jerry. Just real briefly, myself, I'm one of the advisors on the board with Jerry, and Jerry created the Society of Cost Engineers. Background on me, 1971 degree in industrial engineering, operations research from Cornell University, MBA from Northwestern Kellogg School of Management, 48 years of consulting with Deloitte, KPMG, EDS, and then 16 years with SAS, the analytics vendor. If you're doing the math, I'm 73, but I feel like I'm 43. So it's a privilege to introduce Richard Mabe. Going to give his bio, a brief overview of the topic he's going to present, and then hand it off to Rich. So Rich Mabe is a solutions consultant for Unison Cost Engineering. He has over 45 years of operations analysis experience. He has served as civil service employee as a federal contractor, specializing in logistics analysis and cost analysis for U.S. government programs. Rich applies industry best practices to estimate life cycle costs for software and IT systems. His experience includes hands-on data collection, cost estimating, and program management. Rich holds a BS degree in geology from Boise State University and a Master of Science in Logistics Management from AFIT. Just a paragraph or two of the abstract that Rich submitted to me, and then I'm going to have him take off. Software developers don't generally understand cost estimating, and cost estimators generally don't understand software development. Adding Agile to the mix makes the situation even more challenging. Agile software development practices put the development team squarely in charge of cost estimates for short-term deliverables. And these teams, once they have developed a cadence, can be very successfully estimating in this context. Cost estimators have a heftier and less certain responsibility for estimating the software project as a whole, at least for the minimal viable product, MVP, and not to be confused with baseball MVP. Clearly, these estimates are approached from different perspectives, but in a perfect world, the software development team would look to the cost estimators for inspiration and guidance, and the cost estimators would look to the software developers for project details. So Rich, I'm going to hand it off to you if you want to add a little bit more to your bio and then take it away.
All right. Well, other than to say I'm significantly younger than the host here, I'm only 70. So, so the idea for this presentation has been forming in our minds. Arlene Minkavich, who's the other co-author, is the chief scientist for Unison Cost Engineering. We've been working on agile approaches for some time. And in the process of working with our customers, I also worked for government for a lot of years. My last civil service job was with the Air Force Cost Analysis Agency, and I was responsible for all the research and model development for software and IT type programs, and then presented those to the Secretary of the Air Force in reviews. So I've been at this for a while, and we thought it would be good to share what we've been learning about Agile along the way. Now, the question that we ask, and that I'm going to get around to answering very quickly, is in the Agile world, do we really even need professional cost estimators anymore? And let me define what that issue really is. And then I want to start comparing and contrasting the software cost estimating team with the software engineering and software development team, and talk about their differences, and in an Agile domain, do those differences matter, and what's a way to work together? So a little bit of background on the topic of Agile. In the traditional world, and by traditional I mean the IEEE 12207 standard we call waterfall, the software engineers and developers are delivering code to satisfy requirements. They may do some estimates for within their own domain, but they're probably not doing detailed budgets. They're probably not doing, certainly not building defensible cost estimates. They're there to deliver software that satisfies requirements. Now, also in that program somewhere, whether you're in a factory developing equipment for the government, or whether you're in government somewhere, wherever you are, there's probably some cost people who are working for the program manager, and they're putting together detailed cost estimates that are going into the budget assessments and affordability assessments. They're not developing code. They're not doing any of the scheduling. They're not doing any of the testing. They're not responsible for delivering any code, but they're there to make sure that the program remains affordable and stays on budget. And they do that by continually doing cost estimates and trade studies. So you can see there's a difference in the general world, even though they're both working on a common program. Now, in an Agile managed program, however, the software team is much closer to the day-to-day working velocity of that program. And they're going to define the scope that they're going to deliver in each increment, generally just a few days before the increment opens. And they're going to base what they can do in that increment on their understanding of their work skills and their velocities, the type of code they're writing. And so they're going to carve out of the backlog a certain number of things that they can do and deliver at the end of that increment, whatever it is. And so essentially they are defining the schedule and the cost when they do that. So we ask the question, given the flexible nature of the sizing metrics they're using, things like stories and story points, and the always changing scope of what to accomplish in each iteration. I mean, you never really know what's going to be in the next sprint until you're planning that sprint a few days before it begins. So given that dynamic and changing and really open environment, if you will, do we need a separate cost estimator in there telling you, no, you can't afford that. No, you can't do that. No, that won't fit. Essentially, another way to ask the question is, is team size and their labor rate all we need to determine the cost and budget now for software programs? And so that's the conversation I want to go into. When we originally put this together, my intent was to put out very provocative statements and start a fist fight, because I was going to go brief a system or a convention of software engineers. And I put out very provocative questions, and I got a lot of feedback that says, yes, you nailed it. So I'll be interested to see what kind of feedback now I get from a more cost-oriented community. So from an estimator's perspective, for estimating software, it's really quite easy to envision a typical waterfall type program. It's that hut 2, 3, 4 march to a schedule. You've got a fixed scope. You've got all these deliverable dates. You've got all these things laid out there, and the estimator can lay that out at the beginning. And then their job after that is to adjust to account for scope growth and schedule delays, which always happen. Agile was developed by the software community to try to avoid those. And so it became more of a, let's not worry about a long-term planning horizon. Let's just look at what we need for the next deliverable, go with that, deliver it, and then move on. What I call hey-ho, go with the flow type of dynamic. And in that dynamic, the programmers regularly adjust scope to meet their short-term defined increments and to match their team resources that are present within that increment to deliver whatever backlog they carved out for a workload. So when we ask the question, given this dynamic of we don't really know for sure what's happening beyond the next 30, 60, 90 days, we're changing the team's construct. We may even adjust that backlog from what we had planned for. Can you even put a cost estimate to that, and do we need it? And the answer lies in who is the recipient of the cost estimate. So the cost group and pricing groups and all those who are writing proposals are working for the program manager. And the program manager still requires some type of schedule and budget for the program. Agile is many things, but it's not ad hoc, and it's not unstructured, and it's not uncontrolled. In fact, it's a management process, a very good management process to deliver working software on a regular schedule. So yes, a cost estimate is still a good idea, even in an Agile program. But what we have to do to make this work, and what we have to do to be successful, is work together as a single collaborative team. So it's no more the cost people sitting over in one room answering questions from the program manager, and it's no longer the software team sitting over in another room doing goodness only knows what software people do. Now we have to maybe sit together in the same room and figure out where each of us can support the other one. And in fact, the cost estimate now can become a very good validation tool for the Agile team as they're setting up sprints and as they're moving forward to deliver software. The software team is looking at some key characteristics that they're going to apply to make sure they stay within budget and schedule. And those same characteristics can work in favor of the cost team as they provide budget and schedule feedback based on the dynamics of that software team. So it becomes a collaborative process. And that collaborative process is what I now want to go into and what I want to describe for the remainder of this webinar that we're doing. So what I want to do is I want to compare and contrast the software team and the cost team with the objective of how do they become an Agile team and deliver an Agile product or Agile capability. In order to do that, I've centered the conversation on 4 characteristics of every software program in the entire universe. And I want to emphasize that, and here was my first controversial statement to the software engineering community, Agile is not a new creative way to write code. It's not a new programming language. It's not a clever way to do things with tools other than a computer keyboard. Agile is just a way for the program manager to manage that program and deliver scheduled or deliver software on a faster schedule, smaller working increments. It's not just one big waterfall that goes on for 3 years and then it goes to test and then it gets thrown back and then it's 3 years behind schedule. So these characteristics of the definition of the product, it is software, the size and complexity of those software items, lines of code may not really matter anymore. The development approach that we're going to use, how are we going to set this up? What do the increments look like? And then the scope and flexibility of the development schedule itself. Instead of writing a schedule that you try to stick to for 5 years, now you're only going to be worried about maybe 2-3 weeks at a time, maybe 90 days at a time. That's part of that development approach that you'll work out. So within the context of these characteristics, I want to compare and contrast what the software team is doing, what the cost team is doing, and what their collaborative role can be in each of these areas. And I'm willing to take questions anytime as I go through this. I don't know if that's traditional for your webinar, but please let me know if there's any questions. All right, so let's start with the product. The product is a piece of software. It doesn't have to be developed software. It can be some type of ERP product where you're just configuring a commercial out-of-the-box ERP program. It can be any number of things, but in the end, it is software that we're delivering. And in a traditional program, the software team will sit down with lengthy requirements documents. They'll define the computer program end items. They'll base it on some industry standards or corporate type WBSs for bid and proposal. And their focus is on describing the entire end product program and then sit down and go to work. Now, in that environment, the cost team is going to parallel that product WBS with a cost WBS. That's the end product and all the components. And then they're going to identify activities that'll consume resources, design, develop, code, test, system test, deliver. And then their focus is going to be on predictive estimates of the labor, materials, and ODCs spread across that lengthy schedule, either the waterfall or the spirals or the increments, whatever you're going to call them. But now in the Agile world, instead of defining a complete computer program end item, complete with all the software you think you're going to write, we're going to describe a roadmap of a minimum viable product or several products, maybe break them down into minimum viable capabilities and describe in a narrative sense capability stories and feature stories. And so now we have just words on paper describing what we need. The analogy I always use when I'm talking Agile, I got a few years ago from one of the FFRDCs where they're talking about, we're going to build a football stadium. And we just, that's it. That's the grand epic story. We're going to build a football stadium. And then we'll write the minimum capabilities such as, well, it's an American football stadium, not a English football stadium. So we have a gridiron, not a pitch. Do we have an indoor stadium and outdoor stadium? How many snack bars? How many bathrooms? What kind of seats? All these things, we start defining them, but we started with that grand epic story of, we're going to build a football stadium. And then as we begin to parse that down and as engineers do begin to work and design, eventually we're going to come up with a backlog of stories that are pieces of software that have to be developed and integrated. So this whole thing is no longer just a lengthy, detailed, 500-page software spec. Now we're just telling these stories and we're beginning to develop. In other words, the software emerges from the process. Now the cost team has to keep pace with that. So in the beginning, based on the experience that we've had, I mean, I've been doing this for let's see, I started doing agile type studies in 2014 when I was with the Air Force, and have continued since then. Um, Working now with a lot of industry people who are building proposals as opposed to independent estimates. The thing that seems to surface over and over again is back here at this level, we really don't know yet anything definitive even about the product we're going to deliver, other than it's a football stadium. So we're going to do, against that grand overall roadmap, one great and large software estimate. We have one delivery of one giant software product. Maybe there's an analogy to something else. Maybe we know rough order of magnitude type things, but we don't know a lot of the details that are going to go into that. And this is particularly critical because for government, we're looking a couple of years ahead to put money in the budget. So, you know, the budget that's being put together for 2 years from now is being estimated today. And so all we have at that point is a grand roadmap, but then we begin to collaborate with the software team to understand their breakout into capabilities and features and tasks. And as the product begins to emerge, the cost becomes more granular and begins to emerge as well over time. And there are some metrics that we can evaluate, particularly as a cost team, to see if in fact we can validate that the software team is working at the velocity and at the quality level that they thought they would. Do their stories make sense? Do their story point definitions make sense? I mean, we can start evaluating that if we're in fact part of that emerging product that's coming out of the product engineering side. And everything can always track back to the grand estimate, but as we get that granularity and as we start collecting metrics like velocities and defect rates and delivered capability, now we can start cross-checking the software team and say, well, you're not quite delivering the quality you said you were. There's still too many defects, or, you know, you only completed 50% of the tasks in the last increment. Maybe you need to rescope or something going ahead. So in the definition of the product, the cost team can start working side by side and providing some cost and budget metrics that will be very helpful in configuring the work going forward. So, summary of the product. What's the same? A WBS still needs to be created. We're still doing some type of software product, and the complete cost WBS will emerge as the complete product WBS begins to emerge. Keep in mind, in the world today, when we're doing continuous integration and continuous delivery, that product, it's going to be hard to say when is the final product emerging, because you're delivering continual working software along the way. So the team now becomes a regular player in that decision process. Now, what's new? Well, the cost team needs to get in there and collaborate with the software team. They need to understand the roadmap. They need to understand the development of capabilities and features and tasks, where they're fitting into the program. They can do some sample forward estimates of, you know, are you right sizing these increments, or do you need smaller task sizes? And working together, the whole product and the whole program begins to emerge. Now, the next layer down, though, is the one that's the most controversial when it comes to Agile, particularly for cost estimating. In the traditional world, we would just go over, they'd say, yeah, my analogy is for 9 million lines of code or 500 function points or whatever it is. And we carry around with us as costers in our hip pocket these clever cost estimating relationships that relate the kind and type of code we're doing and the amount of code we're doing to the general labor hours to get that code completed and delivered. And so we have this very traditional, you give us a size, we'll give you a cost type relationship. But in the Agile world, size is relative. Tasks begin to form out of that product process we just discussed. And the tasks are the workable pieces of software that get integrated into features and get delivered to the customer. So even before one giant product is out there for them to test and develop and sign off on. They're getting many smaller features and working capabilities that emerge and grow into the product. And so size becomes very relative in that domain. And so the software teams, within their scope of their increments, whatever they are they sprints or how long do they last? They're beginning to say with their teams, go to the Scrum Master. Well, that particular type of data table, I'm able to do those in 3 hours, or that's a size 5 data table for me, or a size 1, or something that has meaning to them. That's the key. It has meaning to that software team in the room where they're working. So in order for that to make sense for cost estimating, the cost team has to walk into that room, sit down at a table, and participate real time with that conversation. They need to understand the skills and capabilities of the programmers at any time during any of those increments. They need to know, what is it you're building? Is it an algorithm of some sort for a waveform or a database or whatever it is? They need to understand the types of skills and complexities of the software, which leads to the velocity that the team can produce. And then they need the team's definition of velocity. Is it story points per hour? Is it stories per sprint? What are they basing it on? We need to do a Vulcan mind meld, if you will, to understand what's going on in the software mind in order for the cost estimate to make sense. Now, in some cases, that's always going to be challenging because a software mind is not blocks and cubes. It's always very creative because it's like creating a piece of art when you program something. But cost estimators still need to work in sizable, definitive chunks so that they can attach dollars and hours to those chunks so that the program manager can advocate for a budget to deliver the product. So it requires the cost team to speak Agile, to understand Agile, and then to write cost estimates and configure cost estimates that will incorporate velocity, that will incorporate complexity, but it'll do it based on something as common as the language you're using. So if you're writing in C++, yeah, that's still lines of code. So let's talk about lines of code per hour. There's no problem with that. Now, you may want to call it stories or story points, and in your brain, 50 lines of code is a medium-sized story or something. There has to be a translation key, but that's what the cost people are there to figure out. Let the software team be still creative and speak in their terms, in their narrative, and then we will convert it to normalized statements of velocity, which are good at least for the next increment. And then they may change, but at least we've got something to work with for a few increments at a time. So size will always be relative in an agile domain. It will always be flexible. So now the cost team has to learn how to normalize against things that are still constant. It's still software. It's still either going to be lines of code or functions or function points or something that can be normalized to create a velocity. All right, so the sizing summary: cost is still a function of effort. No matter how you do it, cost is based on the number of hours involved in delivering software. Effort is still a function of how much software are you going to design, configure, build, test, adapt, modify, whatever you're going to do with it. That's where the stories come in. Whatever you're going to do with it, there has to be a way to normalize that to get to the hours of effort involved for that much of whatever it is. And so the software team has to share what's going on with their relative size estimates so that the cost team can depend on something. So they have to collaborate. They have to be sitting together. They have to be working together. In fact, cost estimates, the way we're building them now in Unison, a cost estimate is not so much how many lines of code or function points you're doing. It starts off first with a very detailed description of the cost team, their experience, their capabilities, what's the language they're going to use, what's the general end product that they're going to do. And once you understand the team, attaching how many stories or story points, which is related to features or functions or whatever, that becomes fairly straightforward. That just becomes regular linear arithmetic at some point. But you have to start with understanding the qualitative to get to that normalized quantitative. All right, so those are the two big ones out of the way. Now, the next on approach and schedule, these kind of overlap what I've just been saying. So the approach, instead of going down a regular scheduled waterfall from item 1 to item 2 to item 3, threw it to test, whoops, it got thrown back. We had to skip back to 2. Now we're behind. Everything got thrown out of whack on those schedules back in those days. Agile was invented to stop this type of growth and rework phenomena. So the cost team in that world had a very tough time. And I'm here to tell you, I've been doing cost estimates since the 1970s, and I've had sometimes a very difficult time doing that because cost growth always occurs. No matter how good that looked at the program design review, everything changed as soon as you started writing code. And so there had to be some way to better correlate and better coordinate. There had to be some way for the program manager to not get wallowed down in rework and delays. The Air Force had a command and control program that they were doing for the command posts that do flight management in a battle theater. They tried to rebuild and redesign those for 25 years, and they kept failing, and they kept reverting back to the same old, very old programs that they had written in the 80s. And so they decided to take the whole thing to an agile scope. They were one of the very first software factories in the Air Force to come up with a directed agile project, and now they've developed into a regular working DevOps software factory. And once they did that, they started delivering working software faster, higher quality, and all of a sudden the Air Force is now using software that was so hard for them to do under this older waterfall type approach. So the software team needs the flexibility of defining their deliverables in that type of environment. They need the shorter, faster cycles. They need lots of automation. They need that concurrent actions, doing parallel agile trains, all the things that we do in that world. We want to encourage that because that's been delivering very good software. So this means the cost team is the one that now has to adapt, and we have to become fluent in that domain. We can assume that we're still writing code and building a software product. That's not going to go away. We can assume that hours are still the driving element behind cost. That's not going to go away. But now we have to understand the teams that have formed and the software that's being developed by those teams. We have to be able to interpret what they say is a story or a story point, at least for the next 2 weeks, and give them something for the 2 weeks and beyond what they need. Cost is always looking a little bit ahead, but it's very Markov. All we know about the future is what we've learned from the past. So we start recording that history. We estimate, we measure, we adjust, and we leap forward to the next state. And then we estimate, we measure, we adjust, we leap forward. So costs can be leaping 1 or 2 increments into the future, but it's very much based on what they learned about the characteristics of these teams, the characteristics of the increments that they're working in, and the cost model has to capture that and be able to flow with that, because that's the way the software team is delivering very successfully software. So as the software product emerges through features and capabilities, the cost, the real cost, will eventually begin to emerge, and it will lead to maybe changes in the way that you're organizing some of your increments. Maybe you'll begin to do more parallel type things. Maybe you'll move software up to a future increment or back to a later increment. That type of feedback will come from the cost team, and it will support the development team so that the whole agile team becomes stronger, and that approach becomes an even more powerful way to deliver software. So that summary, the cost team recognizes that code is still being developed and a product will eventually be delivered, but the budget must still represent the full cost at the end of all eventual releases, whenever that might be. So in order to do that, the cost team needs access to the JIRA database or whatever you're using to track and score your agile software development. They need to be able to freely and openly take those numbers and create velocities, create team capabilities, create team characteristics. They need to understand the tasks that are in the backlog. How many of those are build? How many of those are test? How many of those are adapt, modify? What are you doing with those? They need to understand that and be prepared to estimate at some point in the future when those tasks are going to occur, because they have to keep that full picture in front of the program manager. Cost factors themselves are not fixed. You know, the velocity will eventually emerge across a number of iterations. So this idea of estimate, measure, and adjust to keep 1 or 2 steps ahead, keep the program manager informed on what the budget is doing, that becomes the life of a cost estimator now. So instead of doing it in year 1 and then coming back in year 3 for the next milestone, and then coming back in year 5 for the finally to launch the software in the field, no more. Got to be living with them every day in order to do effective agile type development. And then one last one, the schedule, and this is just really redundant at this point. So instead of having that rigid, you know, waterfall schedule across the period of time where you can't start step 3 until step 2 is finished, which depended on step 1. The challenge for the software team in those days was keeping up with a schedule that wasn't even being, you know, was being laughed at, I think, by some of the software people. They are creative. Don't stop them from being creative. Let them go do what they need to do. Let them find better, useful ways to do it. But it just blows the snot out of a waterfall schedule every time. And we all know that. We all knew it was true. And for years, the cost people took the blame. Program manager would stand up and say, well, I'm over budget because I got a bad program cost estimate. And the answer was, no, you're over budget because software is a creative process, not a hut 2, 3, 4 march to a schedule. Well, finally, we're in a world where software is a creative process. The workload is scaled for the next immediate increment. So the only real cost that you can trust to be true is what you've estimated for the next increment plus maybe 2 or 3 into the future. But that's helping you define what's going to go into each of those increments. So that release map that you did up front, that is not the schedule. All you know that is, you know, every 90 days or so, we're gonna release a bunch of features to the field for the users to start working with. And those are going to be developed through a number of sprints. And the sprints will maybe have, you know, these 15 things in them, but maybe in the end, it'll only have 10 of those and 3 of something else. So you have to be flexible. The only thing you can depend on is there will be teams that have skills that can be converted to a velocity that will tell you what type of code can be developed over periods of time. And therefore, that leads to a cost estimate. And by the way, it also validates, have you overscoped the next increment or underscoped based on this historical set of sprints where we've been mapping and tracking velocity? Because remember, the cost team now has full access to that JIRA database as well. So what happens is the initial grand estimate is always a good starting point. You can use that to write a proposal, but it's a bad way to manage the program. So as you begin to open up those features and open up the releases and you begin to start scheduling backlog into different elements along the way, the cost team is right there giving you the estimate plus 1 or 2 steps ahead, tracking what's going behind so that we can better calibrate what's going ahead. It truly becomes that cone that has been shown over years and years that Barry B made famous in his dynamic world. It truly becomes that we're adjusting and the cost is emerging. And as it emerges, it becomes much, much more precise and trustworthy for the program manager. So the estimator becomes an active part of the team in order to monitor and incorporate their dynamics and their measures, not just for the program manager, but also for the software team. Sit right there. I do have one customer, I won't tell you who, but they are using our tool to actually structure what's going to go into each increment and to determine, have they right sized the increment based on what our prediction is saying it's going to take going out into the future. Okay, so the schedule summary, there still needs to be a schedule. Program management is all about scheduling and budgeting and planning. It's a little bit more flexible. It's a little bit more, near term. It's not so much long term, because the long term didn't work anyway. So now the schedule is not driven by scope. It's actually the other way around. And you've probably all seen that very dynamic upside down pyramid where instead of fixing scope and letting schedule and budget go all to crap, now we're going to fix schedule and budget, and we're going to do that by adjusting scope. We're not going to raise the bridge. We're going to lower the river, and we're going to build scope within those time increments that fits, and will deliver working software. And because we're doing that and we're getting working software into the hand of the user, they're going to be happy and everything will eventually emerge. But it's kind of like you'll be running when you hand the baton off to the next one, and you'll just keep running. So to do that, you have to be a single team in order to make it work. So I have one grand summary slide, and then I think I'm at the point where questions are going to be asked, and then we run out of time. So some final thoughts. The cost estimate supporting a budget is still a good idea. It's not only a useful tool for the program manager, it can be a very useful tool, as we've seen demonstrated in programs that we're working with, to help the software team do that increment planning. Give them some feedback based on metrics that you've collected. The cost team may have the best measures of velocity. If they've got access to all that data in Jira, they can certainly do something with it because they need it to forecast ahead. So it would be a very useful way to help block and schedule tasks to go into those increments. It's more, so now the cost estimate is more than just a resource loaded EVM type schedule where all we needed was, the names of the programmers and their salary, and that's the budget. That's not true. That's never been true. But it'll also become helpful as giving them the probability of the success of completing something within those increments, the viability of your schedule. Do you need to start doing more in parallel? And we can throw in the risk that is always inherent in a cost estimate, because remember, it's an estimate, not an exactimate. And so the cost team will be able to bring you a good measure of the cost and schedule budget risk that you're going to be running up against, which is not only good for the program manager, but very good for agile software teams that have to be careful about not overbooking themselves in a specific increment. So in a dynamic, agile environment, cost needs to be as flexible as the choice of the backlog that's being developed. Costers need to be sitting there. They need to be reading the minds of the software people. They need to be studying their Jira databases so that they are a real-time contributor to the success of a software program. That requires a focused cost estimator as part of the team. It's not just a part-time job for somebody to do. And it's not just, well, we know the payroll and we know how long, what else is there? Trust me, there's a lot more than that. Bottom line, again, and I've said it over and over, it's now a collaborative effort where the cost estimator is part of the Agile team. It's not an isolated effort based on old input that's not even valid anymore because the schedule changed twice before you even knew it changed. All right, I am now finished. and I'm ready to entertain any questions that you may have.
Thanks, Rich.
Yeah, hi, this is
Well, go ahead,
Gary,
Jerry.
sorry to interrupt. This is Jerry Collins, again, founder of the Society of Cost Engineers, and I have a quick question for you. This is very interesting, and I come from the product world more than software, and it seems that this could be applied to product development for any kind of new product, not just software. Has that ever been applied, and do you see a potential for that?
There's a very, very strong community that's advocating Agile as a program management tool for hardware and software. The principles of Agile are defined working elements, smaller increments to deliver working capability. I don't know if it would work for an airplane, but like for electronic systems or smaller systems, it would be really hard to say, okay, we've developed the wings. You guys get started with the wings and we'll bring along the motors later. But there are some products in the hardware domain where it would be very useful as well. That drumbeat of shorter cycles with working product at the end of short cycles, leading to a complete product that emerges over time. That is an incredibly valid. Now, the hardware world, a lot of times they're going to call that lean type processes. So you have lean development, lean manufacturing. It's the same concept. It's doing it, lots of automation, shorter cycles, deliverable, useful product at the end of those cycles. It's a wonderful way to go about creating something.
Yeah, and Gary, this may fall into your bailiwick as well, because the majority of the time, at least in my experience, when we're in a new product development, the engineering effort, all of the associated, say, almost SG&A or whatever you want to call it, overhead, is peanut buttered. And this seems like a great way to actually control the cost per project. Maybe it is an engine and you're developing a brand new engine. You get 5 or 10 engineers, you get a couple of quality people, and a way to actually track all of the actual costs versus just the peanut butter of X% of the sales.
Yeah.
Does that make sense, Gary?
Yeah, there's 2 items you're bringing up. When you talk about the overhead, which more correctly should be referred to as indirect expense to compared with direct expense. Yeah, most accountants and CFOs are lazy. They butter spread it by labor hours, units produced. Everyone pretty much knows that activity-based costing is the solution for that. Sadly, very few companies, in fact, less than 5% apply ABC when they should have. If any of the listeners want to know more about it, I've authored books and implemented ABC. Just send me an email or connect with me in LinkedIn. Regarding new product development, we've had previous webinars where target costing is pretty much recommended as the way to understand what the minimum allowable cost of product could be, basically be driven by the price that the market will pay. So it's the opposite of cost plus. Let's just add up all our costs and we'll mark it up 10%. That's not the way to go. So, but I do have a couple of questions here for Rich. They were sent in advance. Some people knew they were not going to be able with a schedule conflict, but they're going to hear Rich's answers, and when they listen to the recording, they'll get them. So, Rich, you ready?
I'm ready.
Here's the first one. How can a cost team be agile, in quotes, if they have to provide budget estimates up to 2 years ahead of budget execution for government agencies? How do you commit to the cost of an agile program that is regularly changing?
Well, it's an incredibly good question. So this is what I addressed when I said in the agile domain, where you have those epic stories that define the viable product or the capabilities, and you're working from narrative summaries, you have to pick the analogy. The only analogy I have for my football stadium is that they built one in the town next door. So I will start with the analogy of the town next door, and my grand overall cost is, boom, it's there. And it's one giant epic story with, millions of components inside. Now, that might work to give you a starting position, but very soon the requirements process requires you to start breaking that into smaller and smaller capabilities, and capabilities broken into features, and features broken down into tasks. That may not happen until a contract is awarded. That may not happen until you're underway. And in the agile world, for software, you don't even know what you're doing 6 months from now. You only know what you're going to do for the next 2 or 3 weeks. So you would have to, at some point, the cost people would need to be involved with understanding what is the general roadmap. Okay, what capabilities might generally come when, what's the general scope? You haven't nailed anything down. Think of EVM, where we have these planning packages, and then we have the workload packages for the near term. The cost will have to have some information. It doesn't have to be definitive, and then of course it can change and vary, but there at least has to be some grand estimate against the roadmap. Then as you begin to execute in the budget year, you can start tracking and controlling. And even as you get closer to the year, as you begin to define more and more granularity, the cost estimates will become better with time. But it does require some assumptions on the part of the cost team. If they know what one team's capabilities are, they can plug that team in to 2 or 3 increments into the future, and give you a reasonable estimate of what they may be doing 6 months from now. The software people will tell you, but I don't know that, and I don't trust that. I might change. Okay, but the cost people still need some of that. So if we have the tractable data of what the software people are actually delivering, the rate that they can deliver, the type of software they're delivering, the characteristics of the team, it is fairly straightforward then to start predicting ahead. But that's where the cost can start throwing in the uncertainty, doing it at the median percentile or whatever it is of the S curve. That's where they can become useful then in feedback to the planning team to help that product emerge through an affordable process.
Okay, well, you have a second question, and just to manage the attendees' expectations, we have 7 minutes, and we will end at the end. It's inappropriate to go beyond the time. And Jerry, I'm going to have you do 1 minute of concluding remarks. So we probably have a minute for, or time for just one, maybe the second question. Here's the question, Rich. When is the ideal time for the cost analyst to use the performance metrics from completed sprints to adjust the overall software program cost?
Well, as soon as you think you have enough metrics to define a steady state, then you can predict forward and do some changes. So once you start a program, particularly in Agile, where it's, the definitions of stories aren't the same from item to item. And so you have to go through a couple of iterations, a couple of sprints or whatever, in order to see the data settle down and become predictable. Now, the engineering domain will swear at me for saying that. No, it's not predictable. It's not supposed to be. But it will be, because you have programmers who are writing code and they do things habitually over time. So it'll show up in the data. So I would stick with the first grand estimate until I'm maybe a little bit further down the learning curve of sprints. And then I would adjust. If I'm in sprint 3, I'd reach out to go through sprints 5 through 10 and give an adjusted estimate for that. And I'd feed that back to the software people too, to tell them, well, you're either ahead of your curve or you're behind your curve. So sprints 5 through 10 may have to be adjusted a little, which means your budget's going to adjust a little. You may have to do some catch up. Overall, you still have to deliver at the end of a scheduled time, but you're going to be showing them where they maybe have to do some adjusting, which is what Agile is all about. So I would recommend, after you've got 2 or 3 sprints worth of data, go into the future again and see where you're at and what your variances are, and make some recommendations up the chain and down the chain, and then let it run for, you know, a few more cycles and do that again. So it becomes a very a cyclic type process, but it's highly dependent upon the data that's being generated within the program, and a package like Jira or any others that do the tracking of what's been scheduled, right down to daily scrums. Just, you know, parsing and tracking and capturing that data for prediction is still the best way I know of to do cost estimating.
Okay, well, we only have about 4 minutes here, so your next answer has got to be 2 minutes, so Jerry can get a couple minutes in. Here's the
Okay.
question. Is there such a thing as adjusting the budget too soon? For example, suggesting a decrease in the budget based on historical metrics that do not reflect the true velocity for a program.
Well, yes, and that's why the cost estimate always has an uncertainty measure. So when you report the cost, you're reporting it at some confidence interval on an S-curve, so that you're mitigating the probability that you've underfunded or overfunded the next period of time. So that probability always exists, and therefore it has to be mitigated through uncertainty. Is it always going to be right? Oh, of course not, because it's an estimate, not an exactimate. But if you're keeping up with the definitions of your teams, if you're keeping your team velocities, you know, reasonably tracked with the data that those teams are leaving behind in each sprint, it will get better, and it'll be like that cone of uncertainty. It will narrow. So yeah, in the early days, you'll probably look bad a couple of times, but eventually it'll settle down. And I know all my, you know, all the Agile people, if you talk to the software community, they don't want you to believe that anything is tractable or anything is predictable, because that works better for them. So it's like, you know, asking Michelangelo to give me a budget for the Sistine Chapel. He didn't know. He might have said, you know, a crew of 50 guys and 100 gallons of Sears Flat White, and we'll be done next week. But instead, it took years and years laying flat on his back on scaffolding, painting with tiny paint brushes. That's software development. So all we're trying to do is push the cost estimate in front of that as best as we can. And we're going to power that with the data that's being created by the software team itself. And that only works if we're living where the software team is and we have full access to everything.
Great job. You are articulate and you explain things in a way that people can understand it. So much appreciated. So Jerry, I'm going to hand it back to you for concluding remarks, and then we'll be done exactly on the hour. Good old engineers here.
I wanted to take 1 second to thank Gary and Rich for presenting and hosting today, and thank all the attendees for showing up. Reminder that the Society of Cost Engineers basic membership is free, thanks to our fantastic sponsors like Unison. And please go to the webpage if you would like to see the recording of this. It will be on the webpage shortly. Thanks a lot, guys, and everybody have a great day.
Thanks, everybody.